Hello, so today we will be doing revision of our previous techniques. The very first technique we learned in our course was base method, and in this base method also we have two cases. One is positive deviation and the other one is negative deviation. Now let's see positive deviation. You remember what are bases? You have to be little more communicative because this is revision class. This is going to be a little bit fast. So you have to communicate with me. What are bases?
10, 100, 1000, 10,000, and so on.
Yes. Any number which begins with 1 and is followed by 0, like 10, 100, 1000, 10,000, and so on. And the next, we learn about deviation. What is deviation? It's the given number minus base. This tells us how far is the number from the base. Right? So if the number is 102, what is its base?
100.
And deviation?
Plus 2.
Correct. For number here the number is 102, its base is 100 and its deviation is plus 2, right? If the number is 1005, what is its base?
1000.
Yes, and deviation?
Plus 5.
Yes, its base is 1000 and deviation is plus 5. If the number is 97, its base is
100.
yes, its base is 100 and its deviation is
minus 3.
minus 3. If the number is 996, its base is
1000.
yes, its base is 1000 and its deviation is
minus 4.
minus 4. That's correct. So this table tells us about deviation. The first two, these are called as positive deviations, and these two are called as negative deviations. Clear?
Yes.
Okay. Then let's try some question based on positive and negative deviation. First I will explain an example and then I will ask you few questions. The first question which I am taking is, 106 times 105. Both are the numbers having positive deviation. Here the positive deviation is plus 6 and here the positive deviation is plus 5. I name this number as number 1, this number as number 2, this is deviation 1 and this is deviation 2. I divide my answer in two parts. This I called LHS, which is left hand side, and this I called RHS, which means right hand side. RHS is obtained by multiplying D1 and D2. 6 times 5 is 30. LHS is obtained either by adding number 1 or and division 2 or number 2 and division 1 or base plus division 1 plus division 2. All these are going to give me the same answer, isn't it?
Yes.
Okay, here we have a rule. The rule says, what the rule says? It says RHS will have as many number of digits as there are zeros in the base. So if the base has 2 zeros, then RHS will have 2 digits. If the base has 3 zeros, RHS will have 3 digits, and so on. Hope this is also clear.
Yes.
Okay. Then for negative deviation, let us take an example of negative division. 98 times 97. Here also we divide our answer in two parts. This 98 has division of -2 and 97 has division of -3. So when I multiply D1 and D2, minus times minus becomes plus. So this becomes plus 6. But the rule says I must write 2 digits in the RHS as the base is 100, which has 2 zeros, isn't it? So
Yeah.
I will write 06 here. Then for LHS, it's number 1 plus division 2. 98 minus 3 is 95. And the answer is 9506. Clear?
Yes.
Okay, ready to do the questions?
Yeah.
If you wish, you can take screenshot and share in group. Today I am not having my phone. So you can take the screenshot of the screen. Okay, then let's move ahead. Yes, anyone can tell the answer. Try doing it mentally, it's very easy.
11442.
Try again.
11342.
Yes, 11342 is correct.
11118.
Yes, it's 11118.
One zero eight zero seven.
Yes, this is 10807. I'm waiting for the answer. Yeah, Tanvi, correct answer. It's 9024. 997 times 996.
Is the answer 993012?
Yes, the answer is 993012. And the last one,
Is the answer 983072?
yes, it's 983072. So you are getting all the answers correct. So we can move to the next technique, isn't it?
Yes.
Okay, so the next techniques which we learned was multiplication by nines. Multiplication by nines had three cases. Case 1 is when the number of digits in the multiplicand and the number of nines in the multiplier are same. 64 times 99. Here we divide our answer in two parts, LHS and RHS. In LHS we apply 1 less than the number. That is, we subtract -1 from this number to obtain LHS. LHS is 63. For RHS, we apply all from nines and the last from 10. This simply means I have to subtract all the digits from 9 and the last digit, that is the units digit, has to be subtracted from 10. So 9 minus 6 is 3, and 10 minus 4 is 6. So the answer is 6336. Okay. Here we had a special case when the number ends in 0. For this case, the LHS is same, that is 7499. Just I subtracted 1 from this becomes 7499. But to apply all from 9 last from 10 in RHS, the rule says consider the first non-zero digit from the right as the last and followed by equal number of zeros. You remember?
Yes.
Okay. So this is 9 minus 7, which is 2, 10 minus 5, which is 5, and then followed by 2 zeros. Right? This is our case 1. Now for case 2. Case 2 is for extra 9s. What we do for extra 9s? In this, we divide our answer in 3 parts. Let's see how. 73 times 99999. We divide our answer in 3 parts. The first part is same as we do in this, that is 73 minus 1, which is 72. The third part is also same, all from 9, last from 10. In the second part, that is here, I will put extra 9s. Now, how many 9s are extra? Here there are 2 digits. So leaving behind 2 9s, I find 3 9s are extra. So I will put 3 9s over here, and my answer is 72,99927. Got it?
Yes.
Fine. Now case 3. Case 3 says 28 times 999. Now what you have to do? You have to count the number of digits and number of 9s. You will see that here the number of 9s are more. So this is not case 3. Sorry, I am very sorry. This is not case 3. So case 3 says when the number of 9s are less. 285 times 99. Here the number of 9s are less. So when the number of 9s are less, we divide our answer in 2 parts, LHS and RHS. For LHS, we count the number of 9 and leave behind as many number of digits. Here there are 2 9s, so I will leave behind 2 digits, and the remaining part, that is 2, is increased by 1. In Sanskrit, we call it ekadikein purvein. In English, we say one more than the number. One more than the number. And in simple language, we add 1 to this number and subtract it from the original number. I will get 282. And then for RHS, we apply all from 9, last from 10 to as many number of digits as there are 9. In this case, for 2 digits. So this becomes 9 minus 8 is 1 and 10 minus 5 is 5. So the answer is 28215. Got it?
Can you explain the RHS, please, again?
RHS is all from 9, last from 10. We apply RHS to only 2 digits as we have 2 9s over here.
Okay.
Okay. Now ready to do the questions yourself?
Yes.
Okay. Just answer this.
Is the answer 3465?
Yes, the answer is 3465. Correct answer. You can add 1 to 2. It becomes 3 and subtract 3 from this number. 29 minus 3 is
26.
26, and then all from 9, last from 10 to only 1 digit. So 10 minus 9 is
1.
1. So the answer is 261. 74 times 9999.
Is the answer 739926?
Yes, the answer is 739926. Good.
Is the answer 342?
It's 342. 4. So you get 34, and then all from 9, last from 10 to only 1 digit. So it's 342. Few more examples before we move to next technique.
Is the answer 127215?
Yes, the answer is 127215. This is correct answer.
Is the answer 259974?
Yes, the answer is 259974. So these techniques are also clear, all the three cases, case 1, case 2 and case 3. No problem for that.
Yes, it's
Okay. Oh, okay. So the next one is addition. In addition, we solve the questions by making the brackets of 10. Right? Let us take an example. 1094 plus 2683 plus 2749 plus 3522 plus 1784 plus 1596. So when we add these numbers, what we have to do, we'll start from the top, and whenever we cross the sum as 10, we will put a dot over here, over there, okay? So if this is 4, then 4 plus 3 is 7, 7 plus 9 is 16. So I put a dot over here, and then I will proceed just by taking 6. Now 6 plus 2, 8, 8 plus 4 again 12, so I put a dot over here, and I proceed by taking 2, 2 plus 6, 8. In the next step, what I have to do, I count the number of dots. Here there are 2 dots, so I will begin with 2, right? So 2 plus 9, 11, so I put a dot over here in the first step itself. 1, 1 plus 8, 9, 9 plus 4, 13. So I put a dot over here and I proceed with 3, 3 plus 2, 5, 5 plus 8, again 13, so a dot, and I will proceed with 3. 3 plus 9, 12. Again a dot and 2. Now I will count the number of dots. There are 1, 2, 3, 4. 4 dots. So I will start with 4. 4 plus 0, 4. 4 plus 6, 10. So a dot over here. 0 plus 7, 7. 7 plus 5 is 12. So again a dot over here. 2. 2 plus 7 is 9. 9 plus 5 is 14. So 4 and a dot. This becomes 1, 2, 3. 3 dots. So I will start with 3. 3 plus 1, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 3, 11. So 1 and a dot. 1 plus 1, 2. 2 plus 1, 3. And in the last step, we just count the number of dots and tried. So here the sum becomes 13428. Is this clear?
Yes.
Good. So after, oh, I made a mistake over here. It's addition. ADDITION, addition. Okay. So after addition, it was multiplication. Two digit into 2 digit. Multiplication 2 digit into 2 digit. In this we obtain answer in 3 easy steps. Let these dot represent the digits. So in first step, we multiply units digit by units digit. In the second step, cross multiply and add. And in the third step, multiply tens digit by tens digit. In each step, you are allowed to write one digit and the second digit will go as carry. So let us take an example. Say the example is 63 into 47. So the first step is going to be 3 times 7, which is 21. So I can write just one digit. I will write 1 and 2 will go as carry. Now 7 times 6 is 42. 42 plus 12 is 54. Plus 2 from carry, it becomes 56. I will write 6. 5 will go as carry. The last step, 6 times 4 is 24. Plus 5 is 29. Clear?
Yes.
Okay. One question for you. 13 times 42.
Is the answer 546?
Yes, the answer is 546. So, all these techniques are clear to you? This was the first part of our mega revision series. Now, in the next lecture, we will do the next techniques of our course that we learned. So the first 6 techniques are very clear to you all. Okay, then see you next week with some other techniques. Till then, bye bye. Have a nice time.
Bye. Thank you.
Welcome.